Hi friends, here we are going to discuss the assembly language program, that is we have to count the total number of how much number is positive, how much number is negative in from the given array, right? So here we are taking a simple number, right? For example, here we are taking the one hex number, that is 05H, right? So first we have to convert this number or represent this number with the help of this binary, that is for this 0 0 0 0, for this 5 0 1 0 1. So this bit says that it is MSB, most significant bit is this, and this is the last significant bit is this. So in normal scenario, when point comes to the given number is positive or negative, in that we can say that focus on the MSB. That's we can say. If this MSB bit is equal to 0, then we can say this number will positive number. Or we can say this MSB of that particular given number is equal to 1, then we can say this number is negative number. Or sometime we use this certain logical instruction is there. It may be a left rotate, left towards the right, shift towards the left. This kind of instruction we use at the time of the assembly language programming. So here we are taking simple one number, that is 05H. Then we represent this hex number into the binary format, that is 0000, then 0101. So MSB here it is a 0 and LSB again here 1. So we just here first number, that is 0, it is MSB 0, so automatically we say that this number is positive number, right? So again, when we are going through the assembly language programming, there is one carry flag is there. When we go through the left shift operation or logical operation, in that time carry flag, the carry flag playing the important role, right? So starting this carry flag is initially 00, right? So here initially carry flag is equal to 0. Then after first number shift to the left, in that time see this MSB is 0, shift to first in that particular carry flag. Initially carry flag is 0, but again from that particular number which is shift here, carry flag again is 0. If this number MSB is 1, so we have to shift this MSB again instead of this carry flag on this carry flag. But here unfortunately 0 is there, so we at the time of shifting the carry flag become 0, right? Then second number shift to this number shift to this place. Same like that, initially carry flag it is 0, so automatically after 7 shifting at the last time the carry flag which count as a 0 will shift to the end of that particular number. So automatically this 0000, that is 0 representation, then 5 it represents 0101. After one shift, this 05 number become the number get here added. So 0000 100, automatically this number become 08 after shifting. And this shifting is very important for the necessary for the particular to identify whether the MSB is 0 or not. First shift it may be a left shift, in that time we have to shift all number by one shift or one bit, we can shift the number. After shifting we can also see that if the left operation, or we can say shift the left operation, carry bit automatically it is set 0 to 1 or 1 to 0. Here first is set as a 0, automatically after one bit set also it is in 0. So we can say this number is a positive number. Why? Because this carry bit is equal to 0. If this carry bit is equal to 1, then we can say this number is negative, right? So this is the very simple way to identify whether the given number is negative or positive. So with the help of this technique, we you we here are taking one array. In that array, we added the 5 numbers, and we have to identify whether this number. We have to identify the count. Out of that particular 5 number, we have to identify which how much number is positive and how much number is negative. And this for this identification, we have to use first. We have to show the simple MSB of that particular given number is very important. The second is the logical instruction. Right. With the help of left shift, automatically total number get updated with carry flag status. And if this carry flag is equal to 1, we can say number is negative. Carry flag is equal to 0, we can say number is positive. Right. So we have to count how much number is negative and how much number is positive from that particular given array. Here in that array, here we have taken the 5 numbers. Initially, we have taken the directories. This is one assembly language program is here, right? So dot model is one kind of directory. Dot model small. Here we use small value. It use the 1 MB or 64 KB memory for the execution. We use the next directory, that is direct data directory. Carry flags equal to, or we use here data byte or equivalent the 0h. If it is to 0h, then instead of array or list, we use the data word here. That is, we use this 5 word or data stored in the list instead of array. We use here list, and then we have to declare the array count or list count. That is 05 number we use in that particular list. Here data we use for the data we use this kind of data for the execution of that particular assembly language programming. Here dot model small is used to allocate the particular memory for the execution, and dot code, these are the 3 directives. Dot model small, dot code, dot data, these are the directives for the assembly language programming. Here move x comma at the rate data, this is nothing but the initialization of that particular data segment. Here we can say, then we have to move whatever data or store on the that particular AS register. We have to move this data into data segment register, that is DS. Here initialization of data segment, then whatever the data store on the data segment, which we have to move this data into the data segment register, which store on the AX or accumulator. We have to move this data into the DX register. Here in some program we have used a subtraction, that is subtraction BX comma BX. Here we use XOR operation between the two BX registers, or here we use the XOR operation between the DX registers. Right. What is the use of this XOR or subtraction? Because here, as per rule, XOR rule is what? When both input are same, then output will be a 0. For that particular, for clear the BX registers, we use XOR operation. For clearing the particular means, we have to BX register is equal to 0. Means the value of that register or whatever the data which is stored in that register, it becomes 0. Automatically with the help of XOR operation, we clear that particular register. Right, we clear that particular register. So XOR operation indicates that clear that particular registers. If we clear the BX registers, clear the DX register, data register and base register, that is both are the segment registers are here. Then we have to move the count into the CL registers. Again offset, or we can say pointer of that particular list or array. Here we use list, point to the particular pointer of that particular list is point to the source index. Whatever the data which is stored on the offset or list, we have to move into the source register or source index. Pointer points to the that particular source index. Right. See here again the source index, whatever the content which is stored on the source index, move into the AX register accumulator. Right. Here we use the label again. So as per above discussion, as per above discussion, first we have to focus on the carry flag or carry flag, and we have to focus on the shift left or rotate left or shift left. We have to just first clear the carry flag, then shift the content of that particular whatever the content which is we have number which we have taken. Those number first number get moved into the carry flag, and that is MSB. MSB move into the carry flag, and other the number which is shift one by one with left side, right? So here we clear the content of the carry flag or CL flag. Then we have to whatever the content which is stored on the list, we have to move into the source index register. It is one kind of segment register. Again, this segment registers move the content which is stored on the segment is to move into the AX register. See here, SHL shift left, whatever the by content stored on the AX register by 1 bit. If at the time of shifting the content for 1 bit at left side, in that time the MSB is equal to 1, automatically given number is negative. If it is equal to 0, automatically we can say given number is positive. So X is move 0 1 comma X, in that time carry jump the carry. When is equal to 1, automatically negative is there, so we can say increment the data segment register. If G is equal to not 1, then we can say directly increment the BX register, right? Jump to the next, means we have to add the next number. With the help of first number we can add or shift particular to left side. We have to jump, we have to see the carry, if it is equal to 0 or if it is to 1. If it is equal to 0, so we can say the number is positive. Same like here again, 0 to number we can add into the source index register. Automatically we have to say decrement the clarify. Again we see jump is not equal to 0. Again we have to go for the this label. Again we have to move the left. Again we have to check the 5 numbers. We have to again shift the left. We have to set the carry flag. Again jump to the negate. Again we have to switch to the, we have to count the 5 numbers. We have to go to the 5 numbers. Again we have to calculate whether this number is positive or negative. How much number is negative, how much number is positive from the given list, or we can say array. We have to check the carry flag. We have to check the rotate operation, right? So these two instructions are very important, right? These two instructions are very important. If it is positive, then we have to take carry flag is equal to 0. So after completion of 5 bit 1 2 3 4 5, here we have taken 1 2 and we have to loop execute till the 5 numbers which is stored on that particular list, right? Again this last move for ch comma h and 20, these are the terminate the program, enter the program, and end of this program. Same like normal program, we have to just give the initialize the directory model.mol. We have to initialize the data segment. In that we use get clarify 0h. If we use this kind of equivalent, or we can say if you data word for the 0ah, here we use 0dh. Then we, instead of array we use here list, where in that list we use the 5 numbers, right? So we declare here 5 list of numbers. Then in this code from our code directory we use the initialize the data segment, then initialize the accumulator, move this x comma into the data segment register. Here we use XOR BX XOR DX means we clear this particular register with the help of this XOR instruction is used, or XOR table. We will discuss the XOR table in digital electronics. Both inputs are equal. If it is 0 0, automatically output will be 1. If it is 0, if it is 1 1, automatically output will be 0. So we have to clear this particular flag or reset this flag BX and A. Again we have to count which count must store on the CL register. Again whatever the content store on this list, we have to point this content into the